So thank you for having me. I'm Luis Ibanez. I've been teaching an open source class here for about 6 years now. And I work for Kitware. We're an open source company, and some of my colleagues are here, Brian Elba, that some of you may know. We're also going to be teaching the open source class at SUNY Albany in the fall, and we have some SUNY collaborators, Catherine Dumas, Dima Kasab, and Kirsten Jesami. So they have also an open source team going on over there, and I'm looking forward to have more interactions between the two colleges and the campuses. And the topic that I want to share with you is a follow-up of what Ed Fennell talked about. And is, what is Ed coming up here to talk to you? You are not medical doctors, you are not politicians, you don't have too much economic power yet, but one day you will. The reason why he's looking for you is because a large fraction of the problem in healthcare is about information. And that's what we do. So our informatics and computational background is a very important piece of the puzzle in healthcare. We use in the United States 20% of GDP in healthcare. That is $3 trillion a year. That's a lot of money. Just the fraction that we use for hospitals is larger than the fraction that we use for the Department of Defense. And I'm not saying that that's a bad use of the money. I'm just giving you an idea of how much money goes into it. Just the increment of expenditure in healthcare for 6 months is larger than the entire revenue of the whole software industry for a year. Okay. Just the extra increment, just the delta, is more than the revenue of the software industry. So just to put things in perspective, this is why healthcare really matters a lot for everybody. And with the background that you have, the capacities that you have, there is a lot that you can do in that space, right? So that's what those topics come up. And the point is that a lot of the problems in healthcare are about information. What do you know, and how to apply that knowledge, and get it in an effective way, quick enough, clearly enough. So it's a lot of knowledge. You have to know what the patient has. So the diagnosis problem that Ed was describing, having a person go through 6 years of healthcare with the wrong diagnosis is a triple problem. On one side, is not getting treatment for the real problem that they have. And on the other hand, they are getting treatment for things that they do not have. And those treatments, because they are not adequate, they are creating new problems. So you enter in that spiral of chronic disease, where the drug that you got and the operation that you got but you didn't need it is making you sicker and sicker. Of those $3 trillion that we spend in healthcare, 75% goes to chronic disease. So the very, very sick patients, there is a small percentage of very sick patients that take 75% of that expenditure. And part of the problem is that we are not very smart about how we manage information. It's a very difficult problem, and the background that you have can make it a lot easier. So there is a problem of diagnosis, and there is a problem of how you treat it. And they go together. So you can only start treating properly once you know what you actually have. Ed was describing the problem in rare diseases, but it's not only there that the problem exists. When you go to the doctor, 26% of the time, you're going to get the wrong diagnosis for the common of things. Right? The normal patient going to the normal doctor. Of course, the rare diseases community have an even harder challenge, but for everybody else, it's still 26% of the time. Here's an easy case. So the appendix that we all carry, you may have had appendectomies. It turns out that about 15 to 20% of those are misdiagnosis. Right? This is like the common cold kind of thing. Everybody has seen this for decades, maybe hundreds of years. We still fail to diagnose it correctly 1 in 5 of those cases. And so we spend $1 billion a year paying for surgeries that people do not need, just in appendectomies. So if you start looking at the spectrum, then you can understand why do we spend $3 trillion a year on healthcare. A large fraction of that goes to healthcare that we don't need. And the complications that follow, because once you have this appendectomy that you didn't need it, a fraction of you is going to have infections, a fraction of you is going to have complications, hemorrhage, and so on, and then you become one of those sicker and sicker patients that suddenly you did not have to be there. And entering on all that cycle of spending and detriment of healthcare. So what we can do in this community is build information systems. That's what we are good at, dealing with databases, web servers, Python code, PHP, all that technology that we tend to use for certain applications, we can apply to healthcare and is strongly needed. If you have gone to any hospital recently, you may have noticed, if you go to your normal doctor, the standard mechanism for managing information in healthcare is paper. Pencil and paper, pen and paper, that's the standard technology. There are some advantages to doing it that way, but there is a cost to doing it that way. The standard methodology for transmitting information in healthcare is the fax machine. How many of you have used a fax machine? How many of you still use it for something that is not related to healthcare? What do you use it for?
My business.
What do you send with?
Like information for the state government and stuff. Like
okay.
Require it for certain things.
That's interesting to see. What?
Making a really, really, really poor photocopy.
Fax machines are very good at that. Yes. So when you think about it, so we have this large industry or community that spends 20% of GDP, and the way they manage information is through paper. The airline industry had computers in 1946. So just after World War II, the airline industry was computerizing records. Up to 2009, only about 12% of hospitals have computerized records. You go to a hospital, you're going to be managed by paper. The situation is critical for patients that have chronic diseases, because what happens is they go to one doctor, they go to a second doctor, they go to a third doctor, and the records get scattered across the system. What you did to them, the next doctor doesn't know, the next doctor doesn't know. And suddenly they have all these conflicting, missing pieces of information. If you're a person like Ed, you end up carrying your bag with all these papers. You become a gypsy in the healthcare system, and you carry all the data with you. That's how it works. All right, but the technology is there, and we use it every day. We use it for watching videos on YouTube, sending Twitters, text messages, stuff that doesn't matter. We use that sophisticated technology. All of you have supercomputers in your pockets, and we use them for things that is not working. So the goal is to get engaged in things that are more interesting, things where you can apply your knowledge and the technology that you have at hand to real problems that are very serious. So this is what we do with Twitters, right? Tweet and say I'm bored. And here's the sad aspect of it, is that while we are doing this with the network and the internet and the supercomputers that we have in our pockets, quad-core cell phones, that's what we carry, with gigabytes of RAM. In the meantime, people who has a rare disease is sending data through fax and copying information in paper, and storing and getting lost. So you saw when Ed was describing how he managed to get a diagnosis 6 years later by entering data in a database. And he did that by looking at all records in paper and just grabbing two words. It shouldn't take that long while other people are sharing videos of cats and using all the bandwidth of the internet. So there is something broken there that we should fix. Now, some people are smart about it. So this is an example of a rare disease community, it's the MCM community. It's a similar case to what Ed was describing, very few cases in the world. And they use Facebook as a way of creating a network of their patients. And this is their specialty. They are also in that situation where doctors do not know this disease. They don't understand it. It's a disease where the children get growth disorders. When you think about it, just think on type of information. What is it that the body managed to have your arms of the same length? How does the body manage to have, as you grow, ensure that both arms are of equal length? Right? So there is no central processor. How that coordination happens, it goes all through your genes and the mechanisms of morphogenesis. So it's a very intricate process that we do not understand. What these kids have is a broken piece in that system. Whatever regulates your symmetry, left and right, is not working for them. So you have children who may be 7 years old on the right side, but 4 years old in the left side. So they have larger arms, larger brain, and a lot of complications. So you can imagine that as the body is trying to function on a daily basis, then many complications arise out of that. So anyways, it's one of those communities that do not have a treatment. They barely have a diagnosis. And the best thing they have is to cope with how other parents in other places of the world have managed to take care of their children. This particular community gets more of their information from Europe. Because in Europe, it's actually required that parents keep paper records of their kids. So every time that they go to the doctor, they have a notebook that they have to fill up in order to get the reimbursement for their healthcare system. So their socialized medicine that we are so worried about is actually a lot better at managing information because they have to keep all the records. While in America, we are not required to do those things. So many of us do not know what the vaccinations for our kids were. You probably don't know what your vaccinations were. There is no records. And if you're lucky, you may be able to go back to your town doctor and ask for the paper records. But you have to go there. You cannot go online and find them. All right, so what we're doing with Ed is to come up with a project that is achievable by using your skills, and use this project as a pilot project for our open source class, both in SUNY and here. So the idea is we're going to develop this project as an open source typical project, cut it into very small chunks so many of you can do small pieces of it, and together essentially crowdsource all the effort. So we will have it in GitHub. We created this organization. Those are, by the way, the pictures of the two girls, Ed's granddaughters. And this is the first project that we created there. So we have this naming zero repository, and the idea is to have a very basic system. So part of the principles of open source is that you create a mechanism for iterating rapidly and starting from scratch. The first thing that you have to forget is, or when you're working in projects, in open source projects, is you don't want to try to solve the final problem in a single shot. That just doesn't work. That's why the software industry wastes 70% of projects into failure. The software industry wastes about $800 billion a year in failed projects. We do that every year. Projects that never get to completion. And that part of the reason why we do that is because we try to solve them the way we build bridges and the way we build cars. And software is not like that. Software is a different nature of thing, that you have to grow from very small pieces. So you don't develop software, you grow software. And you have to start small with very focused requirements, and then you grow from that as users start exploring what you have built. So this is going to be an application that has the typical, model view controller setup. So you have a database, you will have a bit of logic somewhere, and a web front, because we want that to be accessible to desktops, iPads, mobile devices. And the initial features that we're crafting for this application is to capture basic information from children. You will be surprised, but the problems they have are trivial for you. They do not have algorithmic problems. They do not have large-scale database problems. The problems these communities have are of the range of keeping a list of the names of the children, keeping track of their height and weight every year. That's the kind of problem they have. While we are using the internet to send pictures of cats, these people have problems that are basic, really basic, that you could almost solve with a spreadsheet. But they just don't have the technology, they don't have the access that you guys have. So this is what we have. We created this repository there. We're using the wiki pages of GitHub to keep track of the project. And this is what we start crafting as the basic kind of database design. So essentially what you have is a community of children. By the way, somebody asked about the HIPAA regulations and the privacy of patients. So just to make a point about it. It is a strong requirement for organizations to respect the privacy of patients. But patients themselves can do whatever they want. So the difference in these communities when it comes to privacy and management of records is that if you are the patient and you want to share your records online, that's your problem and you can do it. Your doctor cannot do it, and the university can do it, but the patients can do it. So it turns out that it's very hard to get medical data when you work with hospitals or with universities. But when you work with patient communities, it's very easy to get access to data. And the patients are extremely motivated to share this data because this is how they get better, or their communities get better. So essentially, this is what we're crafting. If you're thinking in terms of SQL, you guys are into databases. I guess some of you use SQL, MySQL, or non-SQL databases, whatever is your favorite. So this is kind of what the tables will be in this particular setting. So you will have parents. The site is, of course, designed for parents to enter information. Parents will have multiple children. And what we are trying to keep here is growth records. Very simple, just, on February 25, it was weighing 10 pounds, one entry in a table. The next day is weighing, so we are talking about 3 pieces of information and records that are very simple. But they have to be kept in an organized way. Typically, they track height, weight, and the head circumference. So it's not rocket science, it's just sad that they don't have this technology yet. You look around and nobody has this online. And then the second aspect that is really important for the rare disease community is to have symptoms accumulated. So they just capture whatever the doctor is observing during their visits. Even if it's not a diagnosis, it's just a symptom, whatever they are observing. Just keep track of that. shouldn't be in a notebook, or it shouldn't be in some facts, with blurry characters. It should be online where it can be searched and data mined. And in addition to that, there's a community of clinicians, the specialized clinicians who are familiar with some of those rare diseases, who will be interested in keeping an eye on these records, because as Ed was describing, we may be looking at problems where there are only 50 people in the planet who have this problem. So whoever is the researcher in the world who is specialized in that particular rare disease, any case, any extra case that they can find is interesting for them, is useful for them. And the same way that you can find any type of information in Facebook and using Google and the online searches, it should be easier for these doctors to search records and say, I'm looking for new patients that may have any of these symptoms or combinations of symptoms. It's just simple SQL query should be accessible to them. And then have the cycle of communication between them. So that's the kind of system that we are looking at building. When you look at the technology that are being used for that, everything is out there. It's PHP, it's Python, Web2Py, whatever database you like, whatever web technology you like. But these three pieces are very simple. We're not talking about rocket science in order to develop one of the systems. So we have created already teams in this project. So I invite you to join any of these projects. If you are participating in one of the open source classes or want to do it as part of your free time, between 2 in the morning and 4 in the morning when you're not doing anything else, then you can join any of these groups. And something that is very interesting when you're confronting this type of situations is, what is it that we are doing it? What is it that has not happened before, and how is that we let this continue not happening? When you look around yourselves, you are the age of Linus Torvalds. So you are the age that Linus Torvalds has when he started the Linux kernel. You have the age of Larry Page and Sergey Brin when they started Google. They were guys like you. You have the age of Mark Zuckerberg. So the question is, could we work on things that do matter and use technology for things that are significant and actually have an impact in society? That's what I have. Thank you. Any questions, comments? Yes.
So you're trying to build this at the public level rather than specifically physicians' access?
Yes, this is not for physicians.
Okay.
So it will be nice to have some specialized clinicians to have access to it, but this is primarily for families. And when you look around, there are now many systems for keeping personal electronic records. Google went out of that business when they closed Google Health 2 years ago. The only options that you have out there are the Microsoft Vault, there's a Vault, and then you have a system called In Vivo, but then somebody has to set it up. So there's the software, but then somebody will have to host such a system. Yes?
So there's this other school of thought that says that the reason most software projects fail is because of bad management. And management, not in the abstract telling you what to do sense, but the how do you get 12 people to work together?
Yes.
This is a really hard problem. So my question is, how are you going to get these people to work together, given that there's 30 kids in each class, and there's a bunch of other people who are floating around, and it all has to work together, and someone has to make the decisions on what we're doing and how we're doing it.
Yeah, you hit the,
We should have a presentation on soft skills. That would probably help a little bit, maybe as we get closer. That's something I'm looking at, soft skills that they develop in the open source community. But how to actually work together is great.
Yeah, you're absolutely right that the reason why projects fail are never technological problems. It's not about the technology, it's always about the people. It's somebody being a jerk, and maybe 2 of them being jerks, back and forth. And it goes back, the way to prevent that is to develop soft skills that we geeks are very poor trying to do. So it's a critical need. When you look at how open source projects fail, are you familiar with Holo? The Holo project? So they track 500,000 open source projects. Half of them are 1 or 2 guys. And when you think about it, the Linux kernel started with 1 guy, so you went into 10,000. And you have to wonder, what is it that these other 250,000 projects are still 1 or 2 guys? What the 100, 300, 500? And it goes back to that, just being nice to other people, being okay with imperfection is very important, and learning how to manage community. It's a lot about this governance, the coordination of
the project is almost never about the technology. Because if you have a community that understand each other and they get along, they will always figure out the technology. The technology is always solvable when you have the human side taken care of. But the other way doesn't work. You may have perfect technology, but if people don't get along, they just break into projects. So that's one of the things that we're going to be working a lot with Catherine and other people at SUNY. And it's not only an open source problem, it's an industry problem. It goes through all software projects. A lot of what happened in those projects is people's issues. Yes?
So not to be rude to either of you, I think these are great, interesting conversations and topics, but what both of you just said is, so we're going to do this, and soft skills are important, we got no clue what we're doing, or how we're going to manage it.
Yeah,
right?
but we are honest.
Honesty does a lot of interesting things, but it doesn't build anything.
Well, so here's the key, the methodology that you use in open source. Open source at the core is a philosophy of do it yourself. And the first thing that you have to embrace when you're doing it yourself is accept and be comfortable not knowing. We have no clue, but we're going to do it anyways. And we'll figure it out. So it's a matter of will, commitment, and purpose. So it's not, I don't feel like really doing it. This has to be done. And because we have a common purpose, then we'll figure out how to do it. Ignorance is an opportunity for learning. So you're absolutely right. We have no clue how to do this. We have some ideas of how not to do it. We have seen how it fails. And that's what an expert is. So we have seen many of those fail. But ignorance is never an excuse for not starting, because you will never get there if you don't try. So failure and the generation of failure is very important. You want to create the conditions where failure happens very often, very quickly, very small, so nobody dies in the process. One of the things that we're doing at SUNY is to create the hacker space. You're familiar with the maker space kind of communities? Yeah, it's kind of what you have in RCOS, is a maker space. You have a safe space where if you make a mistake, nobody dies, nobody gets fired, you just fix it. So that environment is how you address the problem of not knowing. And it's actually that exact root, one of the reasons why large-scale projects fail, is because they presume, or they get tricked into believing that they know. When you, for example, how the Department of Defense runs a software project, they have a cycle of development of 7 years. It takes 7 years to go from conception to deployment. And in that process, there is no distracted cycle of iteration. So the opportunity for failure is only one, and it happens at the end of the project and costs billions of dollars. So embracing failure, embracing imperfection, embracing not knowing and being comfortable with it, and still going along for the trip is part of the way you address the issue.